Now it is the time to understand the graphs also. What is a graph? Graph is basically depiction of two variables in a plane. We call it x and y axis and the xy plane. Something is depicted on y axis and the corresponding change in x axis. That is what is being usually we understand about the graph. It could be about anything: population versus time, inflation versus time, petrol prices versus the population, and so on. Any two things you can plot a particular graph. Here in kinematics we'll talk of the kinematics graph in one dimension. The body is moving and the body basically is moving with some acceleration or some velocity, whatever it can have. So we'll take a generalized case. Let's take first of all the case in which we have been taking that the body travels not constantly but various variations are there. For example, we take these equations. You can see these equations. We are saying s is equal to 2t square for 0 to 3. That means for first 3 seconds body is traveling 2t square. Obviously this is an accelerated motion. Second case, we say the body travels in a straight line because s is the function of t only. Third case, body is not moving from 6 seconds to 9 seconds. And fourth case, the body retards from 9 seconds to 12 seconds. So body accelerating first case, moving with constant velocity, remaining stationary, and then stopping down. This is what we are trying to understand. First 3 seconds. Let's understand what are these first 3 seconds. This is the region of first 3 seconds. If you see, this is the region. Till this point, the body is moving with some acceleration. Now 3 to 6, body moves from here to here, and it has got a straight line which says it's a uniform motion. There is no velocity. From this point to this point, what do we see? The body does not displace at all. That means the body is stationary. And from this point onwards to this point, what we see? The displacement is decreased. So this is the equation. Now, first 3 seconds, body accelerates. In this region we can see. Over here, the body is accelerating in this region. 0 to 3. In this, you see the body is not having a straight line, it's a curved motion which says the body travels with acceleration. From this point to this point, we have a constant velocity. The displacement is very uniform. That means the velocity is constant. In this region, the body is not moving at all, and in this region, body comes back to original position. That means the displacement, the acceleration has to be retarding because velocity already has reached. First graph, 2t square, s is 2t square. This is this graph till 3 seconds. You can see the displacement is proportional to t ka square. Second case, we talk of the straight line which is over here. Then body is horizontally displacement graph. That means the body is not moving at all. The displacement is 54 initially, and right now also 54 till 9 seconds. Now displacement starts decreasing, the velocity, the body starts coming back to its original position. Now the body displaces, the velocity decreases. That's the position. Now, in this case, we'll try to plot the same graph on this displacement on velocity time graph. This was displacement time graph. Now we go back to velocity time graph. So let's see what happens in that. Now we'll see in the velocity time graph. Now this is, you can say, velocity time graph. See, we have differentiated the given expressions and we have found the velocity. From 0 to 3 seconds, if you recall, the body was moving with accelerated motion. That means velocity was increasing, and this is the case from 0 to 3. And after this, it's a straight line because velocity is constant. Now in this case, velocity becomes 0, which was the third case, from 6 seconds to 9 seconds. And now velocity decreases. That means the body is under retardation. These are the graph. Velocity first increases, remains constant, becomes 0, and over here body retards. These are the 3 different phases, rather 4 phases of the velocity which we have discussed. Now from where we have got this values, let us understand, let us know that the differentiation of displacement gives us velocity vector. Okay, let's see what are the displacement equations, then we'll convert to the velocity equations. So let's see the displacement equations and then the velocity equations. Now the equation of displacement is written here. We differentiate it from 0 to 3, we get 4t, and similarly all the differentiation are done from the displacement. You can see the velocity. In the second case, the function has got 12t, the differentiation is 12 only. Third case, the function has got a constant value 54, the velocity has to be 0. And in the fourth case, we differentiate and what we get is 108 minus 12t. So these are the 3 cases. Now, this is, we have got the displacement graph, velocity, and we have plotted here. See, velocity graph is coming down, velocity decreases, final value is minus 36 meter per second, and this is how we consider these 2 graphs. Now we will try to interpret these 2 graphs simultaneously. Now I'll try to change the window to make you understand how does it vary. Now you see, please, I'll see both the graphs in one picture only. Just wait a second. This was original displacement time graph with you. I'll be moving the window so that you can understand it well. How does it change? This was motion in one dimension, displacement time, and I now bring back, because both the graphs are over here, you can see these graphs over here. I'll bring back to original shape so that we can find. It's better if you can make it over at your end also, and you can see the difference between these 2 graphs. It is converted here. So from one graph we can understand the basic things, the displacement curve and then velocity and how does it move. If we try to find the acceleration graph also, we can find it. In acceleration we have to differentiate the velocity. So in that case, what will our eyes will go to the velocity graph, which is like this. Now we'll see in this first region velocity is increasing, acceleration has to be constant, positive. Over here velocity is 0, there is no acceleration. Here velocity decreases but there is no acceleration. Here the acceleration is minus. That's what we will get. Thank you. I hope you understand. For more things, we'll join together in the next video. Thank you.